a look at number 1. So number 1's not too bad. When I look at number 1, again, use the same strategies we've been using. So if you look up top, I put some reminders. Opposite operations to eliminate values. Make sure you remember equations and inequalities are different in the way that, remember, if we divided or multiplied by a negative, they flip. Remember that anything you do to one side, you have to do to the other. So those are all things that we've been reviewing and working on. Again, the problems are just getting trickier as we go. So now we're actually in section 2.1. We've been kind of building up to it. So let's look at part A. Part A is not too bad. What would you do first?
So my thoughts then.
What do you mean? You need a pencil?
For number letter A.
A, what would you do first?
So first you would subtract the 3 by 18. Or from both sides,
Both sides, right? So it would also subtract from the 18.
Yep.
I agree with that. So that's a great first step. Just a little, I didn't all of it came out. Alright. So I'm going to subtract 3 from both sides. This cancels. 5c equals thank you. 15. Alright, so I'm here now. How can I undo the 5 being multiplied to the c? Divide. Thank you, Michael. Let's divide. And I get c equals 3. And again, you may use a calculator for any of this to help yourself. Also, remember that you can plug back in to double check your answer. So what is 5 times 3? 15. 15 plus 3, is that 18? So you should get a true statement. If you don't get a true statement, something went wrong. Okay, part B. I know there's a fraction there and it looks concerning. Let's deal with what's being added or subtracted first. How can I remove the 18? 18 removal. How do I do it?
Oh, my bad. Minus 18 on both sides.
Minus 18 on both sides. So I've got x divided by 4 equals. If I do 9 minus 18, I get negative 9. Now, it looks concerning at first, right? Because you have a fraction. But remember what's really happening. X is being divided by 4. What's the opposite of dividing by 4? Multiplying by 4. So we're going to multiply each side by 4. So these cancel. X equals, what do we know negative 9 times positive 4 is? Negative 36. Yeah. And again, we could plug it back in to check our work. So hopefully this section is going to feel a little bit easier since we did some work in the background to get ready for it. Part C. I have an 8x plus 11. Again, I want to deal with what's being added or subtracted first. So what would you do first? Yeah, let's subtract over the 11. I get 32 equals 8x. And then how do I undo that 8 times x, that multiplication? Division. So let's divide each by 8. And x equals 32 divided by 8 is 4. Let's look at the next one. We've got variables on both sides. But good news, they're not going to cancel out with the ones in the warm-up. So that's bonus. Let's move our variables together first. How could I do that for number, well, I guess we're still example 1. How can I do that for part D? What could I do?
Plus 4. I did plus 4 first.
You did plus 4? That's fine. We can do that.
Yeah.
It's kind of, these are kind of like choose your own adventure problems in a way.
Yeah.
Because there are different things that you can do. I like to get my variables together first, but that doesn't mean that's the only route you can take, right? So there are different options here. Okay, so now I'm here. I want to hear somebody new and their voice. Michael, go ahead. Yeah. I'm going to add the 3v over. Let's combine the v's together. So these cancel. I agree with 9. So I get 9v equals 63. And then we divide, and we get v equals 7. Nice. Okay. Next one has variables on both sides too. Angel, what would your first step be for part E? You can, there's really not a wrong answer. You pick what you like.
Plus 27 each side.
Yeah, I like that. Let's get rid of that big, ugly negative 27. And sometimes that's kind of how I look at the problems. I look at it and think, like, what's the most problematic
Gotta be
thing?
thinking ugly though. Why can't it be 27? You know, it has feelings too, you know.
Thank you. Well, just because it's negative, I like to try to get rid of the stuff that looks concerning. So negative numbers don't love. So, or at least not as much as positive. So 5 and 27 adds me up to 32. And that's equal to 12b. So now I'm here. Griffin, what might you do next? Yeah, let's get the b's together. So I'm going to subtract the 8b over to the other side. So this cancels. 32 equals 4b. So Olga, if I have 4b, how could I get rid of the 4? What would I do? Divide each side by 4. You know that one off the top of your head? 32 divided by 4? 8. Nice. So again, that's why knowing some of those times tables and division stuff from back in the day is helpful. It makes it a little bit faster. Okay. Part F. What's the problem with part F, if you had to say?
There's a fraction. So
yeah, let's make that go away first and foremost. I won't call it ugly because the fraction has feelings, right?
What if the fraction called you ugly?
I know, I wouldn't like it. I would be sad. So we won't call the fraction ugly. It has feelings. It Michael doesn't care about his feelings. Okay, so Ava, what might we multiply by to get rid of the fraction? Look at your denominator. 2. Yeah, let's multiply by 2. That's going to help me get rid of the fraction. So always multiply by what's in the bottom. So I get 4x plus 10 equals. So those 2's cancel, so I just have what was in the numerator. And on the other side, I have negative 6x. Okay. What do you want to do? Yeah, we can do that. Here's what happens though. When we add the 6x over, we've got 10x plus 10 equals 0. It's okay. This is okay the way it is, but let's move. It doesn't matter which one we move, but let's move maybe the 10 without the variable. How do we feel about that? Let's move that over. So I'm going to subtract it from each side, and that's going to help me move it to the other side. So it's okay to have it equal to 0. Just know that you're not done. You got to keep going. I think we had that come up yesterday, Miss Littleton, or the day before.
Wait, but if you, all right. So what I guess I'm confused on is, wait. I missed a step. So when you subtract, or when you plus the x, the 6x to the other one, don't you need something on the other side of the equal sign?
There is something. It's just 0.
We're just not used to that, and I know what you're saying.
Yeah.
We can do it. It winds up being an extra step for you guys if you get it to equal 0. What most of you are doing is you're keeping everything on both sides.
Both sides are staying occupied.
Yeah. But the mistake that we're making is we're looking at 10x plus 10, and we know that it equals 0, so now we're just dividing each side by 10, and that gets us the wrong x value. When we don't keep one of each on each side of the equal sign, we were doing yesterday in our practices, so like people were saying 10x plus 10, they were dividing each side by 10, they were saying that x was a positive one. So they were doing the proper, the almost proper, procedure.
Yeah. So let's look at this. So like we said, this is kind of like a choose your own journey sort of problem. So let's talk about what we could have done differently. So this is the correct way to finish solving it out. But what else could we have done? So we could do it this way, but we could also, once we multiply by 2, so we're sitting at 4x plus 10 equals negative 6x. So again, if you want to keep both sides occupied is kind of what I'm calling it, you could subtract over the 4x at this step.
Wait, how come the, when you did the 2 times all the different things, how come you didn't do 2 times 4x?
Because the 2's cancel. These 2's cancel.
So nothing in that, those parentheses get changed?
No, because it counteracted the 2's
Yeah.
counteracted each other. They undid each other.
Okay.
So these undid each other, so I don't multiply by it. But this side truly gets multiplied because it doesn't have a denominator. So did you see what I did here, moving it over? And now we've got some.
The thing that I got wrong was in the
Oh,
in the
okay.
beginning.
Yeah. Keep going.
That's it. It was just in the beginning when
Oh,
I
it was
did,
the
when
first
I did 2
step.
times when I did 2 times the fraction, I did multiply by.
So he made it 8x plus 20, is that what you're saying?
Yeah.
Okay.
And that's a common mistake, yep. Definitely something I've done before too. But again, look here and make sure you see that you could do either way. Like we're gonna get to the same answer. We're not gonna get it wrong either way that we do it, so it's okay. That's why I said it's kind of a choose your own adventure. You can go either direction.